Yeah, so the contents of the first week were discussed by me last Monday during the same duration and was uploaded in a YouTube channel. The link to this YouTube channel can be found in the NPTEL website, and the slides which I used for problem solving, which I used, can also be found in the same link shared by the NPTEL team. Okay, so this session will be every Monday between 6 p.m. and 8 p.m. And we will be solving previous year's assignment problems as well as uh, the current NPTEL, the current course and assignment problems, which whose deadline has been ended. Okay. So as of now, we don't have any problems for the current year, current course, because I think the first assignment, the deadline is this Wednesday. I think so. So first, we will be solving previous year's assignment problems in the session, and also in the first 1 hour, we will be discussing the course contents that were shared. I will be briefing out the course contents that was given by Sir in the second week. Okay, so let me share my slides. If at any point of time you have any doubt, please feel free to stop me. You can unmute yourself and talk. That is also fine. But if you're typing, I will not be able to know because I will be sharing the slide and I won't be able to see the screen. So just stop me in between and then maybe you can ask the questions in um, the chat window. Okay, so that is also fine. Or you can ask the questions at the end of the session. So let us begin. I will first share my slides. Is everyone able to see my slides? Can one of you please respond?
Yes, yes, we can
Oh,
see.
yeah, thank you. Yeah, so just a second. Hmm. So first we will start with the basic definitions. Um, Last week we discussed about design controls, right? And at the end of the topic, we spoke about space requirement. So we will continue with that and some definitions related to space requirement. So one is the road land boundary. So this is the distance. So if you see, this is my carriageway. Carriageway is the way where the vehicles travel, and adjacent to the carriageway, you will be having shoulders, and the entire width of the carriageway along with the shoulders, you will call it as the roadway. And this entire width, along with provisions for drains and also provisions for future expansion. Say if I have only 4 lanes now, and in future, based on the traffic growth rate, I might require 6 lanes. So I need some more land, some more space at the sides for future expansion. So including all that, this is just a hypothetical line. Okay, so including all this drainage, carriageway, shoulders, and future expansion, you call it as the road land boundary. Okay, okay, so this is the road land boundary. And there's something called as the road margin, which has a similar definition to that of road line boundary. So there's nothing much of a difference between the two. And there's something called as the building line. Okay, there's something called as the building line, which is also a virtual line. You will not see these lines on the road. You will not see the NHAI marking boundaries as to this is the building line and this is the control line. This is just a virtual line, but they will know where this building line is because only till here, you will not be having any building construction. From the edge of the road to this line, you will not be having any building construction because this is also for one case, such as for future expansion, and also you need visibility, right? So we will be talking about side distances in the upcoming slides. So for visibility, you will not be for visibility and also for future expansion, you will not be allowing building construction up to this line from the roadway. And this distance from the road land boundary to the building line, we will call it as the setback distance. Okay. Now, beyond this building line, there is one more line called as the control line. So, what is the difference between building line and control line? So, building line is I said that buildings will start will be constructed only after this building line. So this only from this area you will be having the buildings, but this buildings will have a constraint on themselves. Say you cannot construct this buildings beyond a certain height. Okay, so that sort of limitations, you cannot tell a person to construct a building up to a certain limit unless it doesn't have a proper foundation, right? The height of the building will depend on the foundation, obviously, because it has to withstand the entire building. But in national highways or closer to a road, you will be having some restriction on the building height because of the requirement of proper side distance. So uh, till this line, from this line, you will be having building construction, but it will not exceed, but it will have some limitations on itself. And beyond the control line, there's no such limitation. Okay, so that is the difference between the building line and control line. And if you see sir slides, there will be some values given, which sir would have shown in a tabular form as to the as to the minimum requirement, so minimum uh, setback distance. So this is the setback distance, minimum setback distance for building line and control line in different types of terrain. So we saw the different types of terrain, right, in last class: plain terrain, rolling terrain, mountainous and steep terrain. So based on that, the building lines and the position of the building lines and control lines have been given in IRC, and the same has been quoted by sir in sir's lectures. I have not shown that here. Okay, so now moving on to the next topic, which is side distances. So I want to make this session as an interactive one. So um, it would be nice if one of you could unmute and tell what is a side distance, what is your understanding of side distance. No one is going to judge you here, so you can, and no one's going to know who is who. So there's no chance of judgment here, so you can openly speak. So what is a side distance? What is your understanding of side distance? Because when I was in my BTech, side distance was kind of confusing to me. So is anyone ready to answer? Okay, then I will answer it myself. Okay. Side distance, as it is written here, in simple terms, it is the length of roadway visible to a driver. Say you are traveling on a road at any point of time you will be able to see some distance ahead of you, right? And that distance, whatever the distance which is ahead of you, you should be able to see that distance at least to a minimum of sight distance. Say this is my road, and this is my vehicle. Okay, so this is my vehicle. When I'm at this point of time, say I am able to see till here. My eyesight allows me to see till here. Okay, anything that comes till here, my eyesight is able to see. This distance, or we will leave out our eyesight. Okay, we will go to the geometric constraints of the road. So um, our roadway is visible till here. So this distance should be minimum of SSD. Okay. Now when I move able to so when I move forward here, I should be able to see a minimum of sight distance, which will be till here. So at any point of time, the roadway which is visible to you, which is in front of you, should be at least should have a minimum distance of SSD. So what is SSD? We will talk later. We were seeing what sight distance is. So sight distance is simply the distance of the roadway visible to the driver. So that is sight distance. What I'm able to see, what my sight allows based on the geometry constraints, it is the sight distance. Stopping sight distance is the minimum length of the roadway which should be visible to you while you are traveling on the road at every point of time, so that your travel on the road is safe. I think someone has asked a question. I'll just go and see. No one? Okay. Okay, someone has raised his hand. You can ask your question now. Do you have any doubts? Dinesh? Okay then. Please feel free to type in. So we will move ahead. Okay, so at any point of time, so stopping sight distance is different. Stopping sight distance is the minimum length that should be visible to you at every point on the road. Okay, now sight distance is a general term where we say that it is the length of the roadway visible to a driver. So that is sight distance. We will see what is overtaking sight distance, what is intermediate sight distance, and what is headlight sight distance as we move along. So first we will begin with. Okay, there are, so after this we will see what are the different types of side distances. So side distances, it is defined there. It has many types. So the the four types that I said here is based on the movement that you make, or based on how you calculate the sight distance. So stopping sight distance, overtaking sight distance. Okay, so these are the different types of these are um, different types of sight distances based on one type of classification, and the second, these are another set of sight distances based on where you provide the sight distance. Say sight distance on multi-lane highways. Are you talking about the sight distance when you are traveling on multi-lane highways? Are you talking about sight distance when you are traveling on a circular curve or on a vertical curve, or say an intersection like this where you have a signal or without a signal? Signal is not a problem. If it is without a signal, then you should be talking about sight distance there also. We will talk about uncontrolled intersections, so sight distance at a at an uncontrolled intersection, at a priority intersection, and so on. Okay, so these are the different types of sight distances. One is based on the movement that you make, and the other is based on the geometry of the roadway. Okay, now we will move on to stopping sight distance. So let me just check if there are any questions. Okay, Kavita, is there any question? You've raised your hand. I see that you've raised your hand. Would you like to?
Yes, ma'am. Hello.
Yeah, yeah, sure, sure.
Hello.
Come on, go ahead.
Ma'am, I didn't get the different exact basic difference between side distance and stopping side distance.
Okay. Side distance, um, side distance is, see, when you are traveling on a road, the distance which is visible to you in front of you is the side distance. Okay.
Okay.
Stopping side distance is the distance that is required for you to stop the vehicle. Okay, when you plan to stop the vehicle, you will need some time to make the decision whether you should stop the vehicle or whether you should just slow down your vehicle. So that decision, so you need some time to take the decision, and after that you will apply the brake. When you apply the brake also, your vehicle is not going to stop immediately. It is going to travel some distance before it comes to a stop. So this total distance, the time taken for you to to make a decision, so the time taken by you to take the decision, during that time also your vehicle would have traveled some distance. And when you apply the brake also, your vehicle is not going to stop immediately, it is going to stop after some time, after some distance. So this total distance is what is called as the stopping side distance. So stopping side distance is the distance that you require. So when you want to stop the vehicle also, you need some distance, you need to see some distance in front of you. If not, you will hit someone. So that distance is called as stopping side distance. Whereas side distance in general is generally the length of the road, the distance which is seen by you. Okay. Is it
Okay,
clear?
ma'am.
If it is not clear, maybe when we go through stopping side distance and overtaking side distance, it will become clear to you. And even then, if it is not clear, we will go through it once again at the end of the session. Okay.
Okay, ma'am.
Okay. So, as I was saying, so we will begin with stopping side distance. Now, what is stopping side distance and how is it determined? So, stopping side distance. So, let us begin with. Okay, so stopping side distance is the distance that is required for the driver to stop the vehicle. Okay, now why do you need some distance for you to stop the vehicle? Imagine I am traveling on a roadway and suddenly, all of a sudden, I see an obstruction. Say a dog is crossing by, then I need to do something so that I do not hit the dog. There are three types, okay, three movements that I can make, three maneuvers that I can make to stop hitting the dog in front of me. Either I can bring the vehicle to a stop, I can apply brakes to my vehicle and bring the vehicle to a stop. So let me draw. So this is my road and I'm traveling here, and here I see a dog. Okay, either I can apply brakes and bring the vehicle to a stop before I could hit the dog, or before the position of the dog, or there's one more option where you just decide to slow down your vehicle. You see that the dog is only crossing and it is not there, going to be there stagnant. So if it is just crossing, till it crosses, you just need to slow down your vehicle so that after it crosses, you can just pick up your original speed and move ahead. So either you can stop the vehicle, or you can slow down your vehicle, or you can just say there's not enough distance in front of you. What will you do? You will just turn your steering so that you move to some other direction so that you don't hit the vehicle. You move to some other lane. Okay, so these are the three possible options in front of you, so that in order to avoid hitting the dog in front of you. So the worst case is you stopping the vehicle. Others and all will require shorter distance, right? So say you're traveling at 60 kilometers per hour, and if you're stopping the vehicle, you have to bring the vehicle to 0 kilometers per hour. So the distance required for this is going to be more when compared to you bringing the vehicle from 60 kilometers per hour to 30 kilometers per hour. say you are just slowing down the vehicle. So the distance required for you to slow down the vehicle, 60 to 30, it may be just say L1 distance. Okay. Whereas when you want to bring the vehicle to a stop, you need a much more greater distance because you are bringing the vehicle from 60 kilometers per hour to 0 kilometers per hour. So the distance required for you to stop the vehicle is more. So the worst case condition, worst scenario is always the stopping side distance, and since it is more compared to you slowing down the vehicle or you steering the vehicle and moving to some other lane, that you always design for stopping side distance. So you say that whenever I'm traveling on a road, at every point of time, the distance that is visible to me, visible ahead of me, should be stopping side distance, so that if anything were to come across on my way, then I should be able to stop the vehicle without hitting the obstruction in front of me. So this is the concept behind stopping side distance. So at any point of time on the road, the distance visible to you should be at least stopping side distance. Okay. Now, how will you calculate the stopping side distance? How will um, a designer ensure that at every point on the road there is a stopping side distance of length visible to the driver ahead of him? So how do you calculate this stopping side distance? So it consists of two components. One is the lag distance and one is the braking distance. So what is lag distance? Say I am traveling on a road. Let us take the same situation where I see a dog crossing me. Okay, so the moment I see the dog, I will I will take some decision that I should bring the vehicle to a stop, or I told you I should be able to take some decision. Let us say we are planning to stop the vehicle. So when the moment I see the dog, I am going I'm going to take a decision of applying brakes to my vehicle. Okay, this decision does not strike me in one go. Okay, so I'm a human being. I have my reflex actions. I will need some time to think or some time to respond to the situation. So during this time, my vehicle will not know whether I'm thinking or whether I'm planning to brake the system. It will be simply traveling in the same speed as it was traveling a moment ago before I saw the dog. Okay. So during this time, when I make the decision and apply brakes to my vehicle, so that distance is called as the lag distance. Okay. I'm taking some time and lagging behind in braking the system because my mind is processing whether I should apply the brake. My mind is processing in taking the decision. Okay. So during this time, my vehicle will not know whether what I'm planning to. So it will be traveling the same speed with which it was traveling before it saw the dog, before I could see the dog. So this distance traveled by the vehicle during time TR. So this TR, which I was talking about, to take some decision is called as the perception reaction time. Okay, the time taken for me to perceive the obstruction and then react to it. Okay, so that distance is called as that time is called as the perception reaction time, and the distance traveled by the vehicle during this time, it is called as the lag distance. So if you see, I have designed the road for some speed, say 70 kilometers per hour, and then my vehicle will be traveling at an ideal speed of 70 kilometers per hour, which I will call it as the design speed. So this VD is called as the design speed. So it was traveling at 70 kilometers per hour, and during this reaction time also it will be traveling in the same 70 kilometers per hour. Okay, now this is the lag distance. Now let us move on to the braking distance. So what is the braking distance? Braking distance is I have made the decision to stop the vehicle and I've applied brakes to my system. Till now, my vehicle did not know that I'm planning to apply brakes on my vehicle. So it was traveling with the speed of VD. Now, I have applied brakes to the vehicle. Now it is the vehicle's turn to react to it. And so once I apply brake to my vehicle, it has to come to a stop. But it will not come to a stop immediately. Why? Because it has to come down from a speed of VD to 0 kilometers per hour. So this distance traveled by the vehicle after the application of brakes to go from a speed of design speed to a speed of 0, I will call it as the braking distance. Now, how was this braking distance calculated? So this lag distance is velocity is equals to distance by time. So if I want distance traveled by the vehicle during the perception reaction time, then I will simply multiply this PR with the design speed. Okay, so that is the lag distance. Now, how will I calculate this braking distance? Okay, okay. Before that, so Sir would have discussed initially what are the factors that affect the side distances. I wanted to bring in these factors along with the equations. So first, I'm giving you the equations, and then I thought we will see what are the factors that are influencing the side distances on these based on these equations. Okay, so first we'll see one second. First we will see how to find out braking distance. This lag distance we saw. Okay, so we will see how to find out braking distance. One second. Okay, so whenever a vehicle is moving with a velocity and it has a mass, then it has some kinetic energy associated with it. Okay, so when my vehicle is moving with a velocity of Vd, it has a kinetic energy of half mvd square. Okay, okay, so this is the so my object has a kinetic energy. Now this is equal to the friction that is associated with the vehicle. Okay, so yeah, let me go to a new slide so that I can, yeah. So this object will have a kinetic energy. So kinetic energy is equals to half m. So m is the mass of the vehicle and vd square is the vd is the velocity of the vehicle. So the kinetic energy of the vehicle when it is moving at a velocity of vd is half m vd square. Now this change, so this kinetic energy is associated with, so this is nothing but work done due to friction force. So no, let me explain like this. So this is the road, and it initially it has a speed of Vd, and when it comes to rest, it has a speed of 0. So there is a change in kinetic energy, right? So it has a kinetic energy of half mvd square at this point, and it has a kinetic energy of 0. So there is a change in the kinetic energy, and this change in the kinetic energy is because of the brakes that I'm applying, and this braking system, it comes to a stop because of the frictional force between the tire and the pavement. Okay, so I'm going to equate these two. So the change in kinetic energy, which is half m vd square minus 0, is equal to the change in frictional force. What is frictional force? So if I have a vehicle, if I have some body of weight W, then if I'm moving it sideways, say I'm trying to push it laterally, it may offer some resistance based on the friction force between the surface it is resting on and the bottom of that surface. Okay, so that friction force, so if I'm trying to push it this way, for this object to stay at rest, it has to offer a frictional force opposite to the equal and opposite direction like this okay, like this. So that it has a magnitude of W into F. So where W is the weight of the object which we are talking about, and F is the frictional coefficient between the surface of the between the bottom surface between this surface, resting surface, and the bottom of the object. Okay, so this is the frictional force. So this should be equal to the frictional force. Now W is nothing but weight, right? Weight is equals to mass into acceleration due to gravity. So substitute for weight here, half mvd square. One second. So I was saying that kinetic energy is equals to work done due to frictional force. This is nothing but force, okay? But work done is equals to force into distance. So this distance is the braking distance, okay? So this distance is the braking distance, okay? So let us go from first. Sorry for confusing. So so the change in kinetic energy is the work done by the system due to the frictional force, and this work done is nothing but this frictional force into distance traveled. So half into mvd square is equals to wf into lb, where lb is the braking distance. So if you rearrange and substitute for weight as m into g, and if you rearrange, then lb, you will get it as vd square divided by 2gf. Okay, so this is how you will get the braking distance. Now moving on to the factors that affect this side distance. So if you see from equation here, um, for lag distance, obviously in both these terms, the vehicle speed is going to affect the side distance. Since it is directly proportional, since it is in the numerator, so with an increase in speed, my side distance is going to increase. Okay, so that is obvious, very clear. Now, with increase in um, there are some more terms associated with it. G, gravitational due to constant, is constant. Except for some points on the earth, it might vary little bit, but mostly the average acceleration due to gravity, we will take it as 9.81, right? So leaving behind Vd and G, what are the other factors that affect side distance? It is the perception reaction time and the friction coefficient, longitudinal frictional coefficient F. So these are the two factors that affect the stopping side distance. So let us see about the perception reaction time. So it has four components, which we will call it as PIEV theory. So it is the time taken for you to perceive the situation, and then I is for your senses to connect to the brain to say that I have perceived some situation, and then um, your brain will take. So first, P is for you to perceive the situation, that I have seen some obstruction and that I have to do something about it. So you transfer this information to the brain. Now this information goes to the brain, and this brain will take some decision whether what needs to be done, whether you have to stop the vehicle or whether you have to slow down the vehicle, or you just have to turn the steering of your vehicle. So this your brain has to take some decision, and then it has to command your senses to apply some action to it. Say it will ask your leg to apply brake on the system, or ask your hand to apply brake on the system. So this theory is called as the PIEV theory. So for the reaction to go from your body to the brain, and from brain the command has to come from your brain to the system to take some action. So during this time, during this phenomenon, there is some time associated with it, which we will call it as the perception reaction time. Now, this will depend on many factors, such as the experience of the driver, the gender of the driver, and so on, the mood of the driver, the condition of the driver, and so on. Okay, so perception reaction time, it depends on the type of the driver and his characteristics. Now, so this affects the lag distance. Now, there's this longitudinal friction coefficient which will affect the braking distance. So this, what is friction? So friction is a well-known term, right? So what will this friction of the surface depend on? So it will depend on the type of surface or surface condition. Say type of surface, as in if it is a rough surface, the friction will be more. If my tire, so my tire and the pavement are the two components that are going to be in contact while creating the frictional force. So if the pavement is rough, my friction force is going to be more. If my tire is treaded, so you know what a tread is, right? So on a wheel, it will have some treads like this, right? So if it is threaded, if it is a new tire, then the friction is going to be more. If it is a friction coefficient is going to be more, and if it is a worn out tire, say if the treads have gone because you've used for a long duration, then if the tire surface is smooth, then the friction coefficient is going to be is going to be less. Um, and this friction coefficient will also depend on the speed of the vehicle. So all these factors have been discussed by Sir. Okay. And also if the surface is wet. So most important thing, if the surface is wet, say this is my surface, this is my tire, this is my tire. If my surface is wet, there's going to be a layer of water in between the surface of the tire and the surface of the pavement. So this is called as hydroplaning. So this will create a even more smoother surface, thereby reducing the friction. So you would have seen, right, skidding happening in rainy seasons. So it is because of this hydroplaning effect. And if this happens when the tire surfaces, if the tire treads are worn out, it is even more worse condition because your tire is also smooth. There's water in between the tire and the pavement surface, thereby making the pavement even more smoother. So this will reduce the friction to a greater extent. So friction between the tire and the pavement will depend on a number of factors. It will usually vary between 0.35 to zero point 0.4. This is the longitudinal frictional coefficient, and this variation of 0.35 to zero point 0.4 will depend on the speed of the vehicle. Okay, so that tabular column has also been shared by Sir. Now, there's something called as, so this is what we were talking about till now is uh, stopping side distance on a level surface. Okay, so when you are traveling on a gradient, when you are traveling on a slopy region, the stopping side distance will be more or less depending on how you on the slope you travel. If you're traveling on an upward slope, or if you are traveling on a downward slope. Okay, now say if you're traveling on an upward slope, your braking distance is going to be less. When you apply brakes to the system, the lag distance is going to be the same everywhere because it depends on my reaction time. It does not depend on the surface of the road. So lag distance is going to be the same everywhere for even on a slopey region, even when you're traveling on a gradient. Whereas the braking distance, it will depend on the slope because if you're traveling on an upward gradient, when you apply brakes, it will come to a stop much sooner because the gradient is also supporting you. When you're traveling on a downward gradient, there's gravitational force which is against you. So, I mean, sorry, which again pulls you further. So there's an effect of this gravitational force when you travel down the slope. So the stopping side distance or the braking distance will be more when you travel on a downward gradient, and it will be less when you travel on an upward gradient. So how will you take this gradient into effect? You will, yeah. So it is earlier on a level surface, it was Vd square by 2gf, right? Now, if there's a gradient of n, then you just have to include this in the equation like this, where you will use plus for an upward gradient and negative for a downward gradient. And this gradient is usually defined in percent, right? So we say that it is a 2.5 percent upward gradient, but when you are substituting it in this formula, you should not use it in percentage, but you should use it in fraction. So it will be 0.025, something like that. Okay. So this is just an example. So this is how you will include gradient in the equation. Okay. Now, just a second. Yeah. So we will just see briefly how this equation came. Now, we were talking about frictional force on a level surface, right? Here, you have, if this is, let us take an upward gradient, and the weight will always be acting vertically down, right? So the weight will be acting vertically down, which is mg. Now this frictional force, so this has to be resolved into horizontal and vertical components, because see, if you're traveling in a slant, in a slopy region, then the frictional force will also be in that direction only. Okay, so when you are on a level surface, weight is acting vertically down, and when you're trying to move any object horizontally, then the frictional force will be equal and opposite to that direction. Okay, which is again horizontal. Whereas when you're traveling on a vertical, say you are keeping a box on a slopy plane, slanting plane, your weight will act vertically down, whereas your box will try to slide down like this because of gravity. But maybe because of the friction between the bottom of the surface and this plane, the box may remain at rest because of the frictional force, which will be acting opposite, equal, and opposite to the slant. Equal and opposite to the gravitational pull that is being applied on this box. Okay, so you have to take this component, so this slanting component, as well as the weight of the box in this direction. Okay, so that is what we do it in the case of car as well. So we resolve the force into vertical and horizontal components with respect to the plane, with respect to the sloping road, and then this mb square, right? So this is the kinetic energy, change in kinetic energy. This has to be equated with, so this kinetic energy is in this direction. So it has to be equated with the frictional force as well as the horizontal component of the vehicle, that multiplied by the lag distance. So initially you had only the frictional force due to the horizontal component. Now you have the frictional force due to the horizontal component, due to the due to the vertical component, as well as you will have the horizontal component of the vehicle. Okay, so both these forces will be coming here on the right hand side, multiplied by the lag distance. Sorry, multiplied by the braking distance. If you want, I can show it in one more. Okay, so this is my vehicle. Say this is my vehicle. It has a weight of, from the CGs, and it has a weight mg, which is acting vertically downwards. Now I have to resolve the forces according to the plane, direction of the plane. So I have a vertical component for this weight, and I have a horizontal component for this weight. As well as this force, there will be a frictional force between the pavement and the vehicle, which will be acting in this direction. Yeah, sorry, which will be acting in this direction. Okay, because my vehicle is moving in this direction, the friction is in the opposite direction. So this is the frictional component, this is the weight of the vehicle, horizontal component of the weight of the vehicle. So weight of the vehicle, horizontal component. Okay, so these two forces are acting in this direction, and there's this movement of the vehicle with the velocity Vd in the opposite direction, trying to bring it to rest. So you have to equate these two. Okay, so the change in kinetic energy is equal to summation of these forces into the braking distance. From here, you can calculate the braking distance. So this is how the SSD and the equation for SSD and gradient is calculated. This has also been given in search slides. If you have any doubt, please ask me. Feel free to stop me and ask me in between. Okay. Now there is one more SSD which taking into consideration of the braking efficiency. So say braking, the brakes that I'm applying, it is a system, right? It is an equipment which I'm using to apply brakes to the vehicle. It will have an efficiency because it is an equipment. It will have an efficiency. It will not be 100% efficient. It will not if I apply brakes to the system, it will not exactly transfer the braking force to the ground. Okay, so that is what we call it as efficiency. So every equipment has an efficiency, and you have to take that also into consideration when you are designing something. So when you are planning to stop the vehicle also, the braking distance will depend on the braking efficiency of my brakes. So that also has to be taken into consideration, which is brought into effect by this term eta. Okay, so this is the braking efficiency, and it can have a maximum of 100%. So whatever we spoke about earlier, the equations were assuming that the braking efficiency is 100%. This also you will not substitute it in terms of percentage, but you will substitute it in terms of um, fractions. Okay, so 100% means it is 1. So 80% means it is 0.8. Okay, so this is taking SSD, taking into consideration the effect of braking. So in all the cases, lag distance will not have any effect because it all completely depends on the driver's perception reaction time. Whereas braking efficiency will affect the braking distance, and also the slope, the gradient also will affect only the braking distance. Okay. So these are the three cases for stopping side distance. Now coming to overtaking side distance. Now what is overtaking side distance? Why is there a need for overtaking? So let us see if there are any questions. Okay. If you have any questions, please feel free to ask. Do you people have any questions? Okay, so we will move on to overtaking side distance. So what is overtaking side distance? Why is there a need for overtaking side distance? So we've all heard of the term called overtaking, right? When you're traveling on a road, if a person in front of you is so lousy, is traveling very slow, then you cannot be traveling with the same speed as his. Because you're traveling behind him, you will also be forced to travel at the same speed of the vehicle in front of you, unless and until you overtake the vehicle and start going ahead of him. So that is why we have this concept of overtaking, right? So when all the vehicles on the road will not be traveling at the same speed, so there will always be one vehicle which will have the need to overtake a slow moving vehicle in front of it so that it can um, move ahead, right? So that is overtaking, and you cannot overtake anywhere on the road. You need proper distance in front of you. So here also we call it as side distance only, because side distance is what you see in front of you. For overtaking, you need a side distance. For stopping, you need a side distance. Okay. So side distance is a general term, whereas stopping or overtaking, it all depends on the maneuver that you make. So overtaking side distance means I'm going to do an overtaking maneuver. Stopping distance means I'm going to do a stopping maneuver. So this stopping or overtaking side distance will depend on the maneuver that I make, and side distance is a general term which allows me to do that maneuver. So stopping side distance means I need a side distance ahead in front of me so that I can stop the vehicle safely, and overtaking side distance means I need a side distance, I need a distance visible to me in front of me for me to overtake safely. Okay, so this is the main difference between side distance and overtaking side distance, and side distance and stopping side distance. Okay, so there are three maneuvers that happen. So there are three main components of overtaking. So first one is, so let us begin by seeing the vehicles here. So this is B1. So this is the slow moving vehicle in front of you. So I am A here. A is my vehicle and I'm traveling behind this vehicle B. So B1, B2 is the position of the vehicle B. A1, A2, A3 is the position of vehicle A. And C1 and C2 is the position of vehicle C. So they are not different vehicles, but the position of the same vehicle. So A1, A2, A3 is the position of vehicle A at different instances of time. Okay, so my vehicle is A and I am traveling behind a slower moving vehicle B. Okay, so the ideal speed with which I should be traveling on a highways. So if I've designed a highways for 70 kilometers per hour, it will be efficient only if I travel at that speed, right? So I will want to travel at a speed equal to the design speed. I should be careful not to travel more than the design speed, but I will be traveling at a speed, a design speed when I'm traveling on a highway. And this slower moving vehicle, it may be traveling slower than mine because of many reasons. Maybe because of the load that is carrying, maybe it is a truck and it can only pull that much. So it has some reasons for it to be moving slowly on that highway. But I need not travel at the same pace as that vehicle is moving, because my vehicle will have has a higher capacity of moving faster compared to vehicle B. So I want to overtake vehicle B and move ahead of B. So that is what I'm going to do in this overtaking maneuver. So what I will do, so place yourselves in a car A, and then assume that there is a car in front of you, car B, or truck in front of you, truck B, and you are planning to overtake. So what will you do? You will first decide that I need to overtake this person. So during this time, I'm going to travel some distance. Okay, so A1 is the point at which I'm planning to overtake the vehicle, and immediately I won't just overtake, right? I will be traveling some distance behind him to find out the ideal time where I can overtake. So during this time, I will be simply traveling behind B only. I will not be doing any other action, but I will be just thinking or waiting for a situation to move to the other lane and overtake the vehicle. So during this time also I will be traveling behind B only, but for a smaller time, for some time, till I make the decision to move to the other lane to overtake vehicle B. So during this time, let us say it is small t. During this time, it will be traveling at a speed equal to the speed of vehicle B. So if I'm following the truck B, which is traveling at a speed of 50 kilometers per hour, when I'm deciding to overtake that vehicle, I will also be traveling at 50 kilometers per hour. Okay, for some time till I decide to move to the next lane. So this distance I will call it as D1. Okay, so first I'm discussing method 2. So this distance I will call it as D1, and it will be equal to VB into T. So this time is the time required for me to make the decision. Okay, and the vehicle speed is VB only, because VB is the velocity of the slower moving vehicle. So it is VB. So during this D1, I will be traveling at a speed of VB for a time of T. Okay. Now we will see what this T is. T is, it all depends on the driver. Because it all depends on my decision time. So this is how the component D1 is obtained. Now let us move on to D2. So there are three components, as I said, D1, D2 and D3. Okay, so let us move on to D2. Now this D2 is the time taken for my vehicle A to move from position A2 to position A3. Okay, so this is the distance D2. Now now imagine yourself in the car A with a truck B in front of you. You've decided to overtake the vehicle, so you move to the next lane and then you accelerate your vehicle, go in front of B and then go back to the same lane. So say this is the lane in which you're traveling. Okay, so this is the lane in which you're traveling. You will move to this lane, accelerate faster, go faster than B, accelerate your vehicle and then go back to the same lane, right? So this is what overtaking is about. So this is what I was talking about, A2 position, and this is A3 position. So during this time also some distance is covered, which is D2. Now what is this D2 and how is this calculated? Okay, so let me move on to a new slide. Okay, so how is this calculated? Now uh, my vehicle A is here, B is here, so I have to come to this lane, travel some distance and go here. Okay, A3. Okay, so when I'm traveling this distance, no, this B is not going to remain stationary, but it will travel some distance, right? It will also be traveling parallelly along with me, but at a slower speed. So when vehicle AA moves from position A2 to A3, my vehicle B would have moved from position B1 to B2. Okay, and so this is the distance traveled by vehicle B2, which I will take it as B, and this is the spacing between vehicle A and B at any point of time. So this is the clear space between vehicle A and B. So I am sitting in vehicle A. I will not be very close to vehicle B, right? I will leave some space in between, and that distance is called as S. Okay, that is the minimum distance. So you would have seen behind some vehicles that travel like leave some meters behind me and then follow, right? So that distance, that clear spacing between two vehicles is what I will take it as S. Okay, so before making the overtaking maneuver also, I should follow vehicle B with a spacing of S between us, and after making the overtaking maneuver also, the vehicle B should be behind me such that it is at a distance of S behind me. Okay, so there should be a minimum distance of S between the vehicles, and so there are two S's in this D2, and also there is B, which is the distance traveled by vehicle B in vehicle B during this overtaking maneuver. So this entire distance, I will take it as d2, right? So d2 is equals to 2s plus b, right? And this b is nothing but 2s plus vb into t. So what is this capital T? This is different from the small t that we discussed earlier. So this capital T is the time taken by the vehicle A to move from A2 to A3, which I will call it as the overtaking time. Okay. So this overtaking time is taken as capital T, and during this overtaking time only this vehicle B is also moving from B1 to B2. So it is the same as small b. So VB into small t, VB into capital T will be equal to this small b. Okay, so this D2 is equal to this. Now, how will I find out this T? You know what is the value of S. There's an equation to find out the value of S. So value of S is equals to 0.7 VB plus 6. So this is the length of the vehicle, average length of the vehicle. This is similar to the stopping side distance. Say this is the reaction time. Say I'm traveling behind a vehicle and I will be very cautious, right? So my reaction time will be less. If I will be, I'm following the vehicle. So if the vehicle in front of me stops suddenly, I will not, it is not an unexpected situation. The vehicle stopping in front of me is kind of an expected situation. It can do that anytime. So my reaction time is kind of lesser when the vehicle in front of me stops suddenly. Okay, so this is kind of like a reaction time. 0.7 is the reaction time, VB is the speed of the vehicle, and 6 is the instead of taking braking distance, we simply take it as the average length of the vehicle. So this spacing between the vehicles is calculated using this formula. Okay, and VB, we know what VB is. Okay, so VB is the velocity of the slower moving vehicle. So there's one standard formula for finding VB. So you assume that if VD is the design speed of the road, say my speed is designed for 70 kilometers per hour, my VB, that is the slower moving vehicle, is going to be traveling at a speed of 16 kilometers per hour less than VD. Okay, so it will be VD minus 16. So that will be my VB. So VB I know, S I know based on the formula. Now how to find out this T? So this T also has a formula which is T is equals to root of 4S by A. Now how did we end up in this formula? So we would have seen, so last time also I was discussing about the equations of motion. There are three equations of motion. Now we will use one equation of motion here to find out how this T was determined. Okay, so there's an equation called S is equals to ut equation. This is the equation of motion that we learnt in physics, high school physics. Okay, so capital ut plus half at square. So this means that if my vehicle is traveling at an initial speed of u, so my vehicle is traveling my vehicle is traveling at an initial speed of u, or say it is vb. Okay. Now for this overtaking maneuver, you have to increase the speed, right? You have to increase the speed. That is, you have to accelerate the vehicle, and then you will make the overtaking action. During this acceleration, your vehicle speed is not going to remain the same, whereas my acceleration is going to remain constant, right? So you cannot use a constant velocity here, but there is one equation that says that if you are starting at a speed of u, and if you are accelerating at accelerating at the rate of a, so you're starting at say 50 kilometers per hour, you're accelerating your vehicle for around for t seconds, then what will be the distance traveled by you during this action? So you start at a speed of u, you accelerate the vehicle for capital T seconds. What is the distance traveled by you? So S is the distance traveled by you. So this is the one equation of motion, one of the equations of motion. So we will equate this with d2, because here also you're doing the same action, right? You're from at position A2, your vehicle is at a speed of VB. So this is nothing but your u. Okay. And At the point A2, you will accelerate your vehicle to A. Okay, you're accelerating the vehicle by A for t seconds, which is the overtaking time, entire time for overtaking to go to position B. Okay, so during this entire distance, what is the distance traveled by you? That is equal to d2. Okay, so this s is d2, this vb is, this u is the speed of the vehicle initially, which is vb, and t is the overtaking time, and a is the acceleration. Now you have two equations. Let me go to one more slide. So now you have two equations. So yeah, so now you have two equations. One is d2 is equals to s plus b plus s, which is s plus vb into t plus s. So this is also d2, and this there's one more d2, which is d2 is equals to vb into t plus half a t square. Now I can equate these two d2s, right? So 2s plus vb into t is equal to vb into t plus half a t square. So these two will get cancelled, and t will be nothing but root of 4s by a. So this is how you will get the equation of t. Okay, now this, so this is the so this is the equation for d2. So you will find out d2 because d2 is also the time distance traveled by vehicle b, sorry, vehicle b in time t. Okay, so so d2 you will find out like d2 is equals to speed of vehicle vb into capital T, which is the time taken for overtaking. Now, there is one more component called D3. Now, what is this D3? You have seen some vehicle here, capital C, which is traveling in the opposite direction. Now, if I'm traveling, say if I'm traveling on a highway in which the left side there are two lanes and right side there are two lanes, which is entirely assigned for movement in only one direction. So left side I have movement in only the forward direction with a median in between. If there's a median in between, there's no like possibility of having a vehicle in the opposite direction. But say you're traveling on a two-way road. Okay, two-lane two-way road is a vehicle has a road has two lanes, and one lane will be having vehicles in one direction and the other lane will be having vehicles in the opposite direction. If I'm having a situation like this, and if I have to overtake, then I have to move to the opposite lane. So there's a chance of vehicle coming opposite to me and hitting me. So I should be safe of that case also. So you assume that when I'm making this overtaking action, the vehicle which is coming opposite to me should be at a position of C1. Only then, when I finish this overtaking action, it will come to the position of C2 and both of us will be safe. No head-on collision. So let me explain this clearly here. So there is a two-lane two-way road. This is my vehicle A. I'm following B and I'm overtaking this vehicle, and I see a vehicle coming opposite to me. But I should not hit the vehicle, right? I should not collide the vehicle. So for me to make this overtaking action and go back safe here in this position, when I complete this overtaking action at time t, this vehicle should be parallel to me. Okay, should be exactly parallel to me, which means it should have been here at the beginning of the overtaking. It should have been some distance here. Okay, so this distance traveled by D3 is this distance traveled by vehicle C, I will call it as D3. Now let me reiterate. So I'm overtaking and I'm moving to the correct lane. By that time, I'm seeing a vehicle opposite to me. That vehicle should be at a distance, some distance behind, which is this position. So when I start the overtaking action, it should be in this position. Only then, when I finish this overtaking action, both of us will be safe without any head-on collision. So this distance traveled by vehicle C, it is what will I call it as D3. Now this vehicle will be traveling at design speed because it is traveling the opposite direction. It is not traveling slower. We will assume that it is traveling at a design speed for worst case scenario. So it is traveling at a design speed, and it the distance traveled will be taken into account only for the time of overtaking. So what is the distance traveled by vehicle C? This distance d3 will be Vd into T. So during this overtaking maneuver, how much distance it has traveled. So that how much distance the opposite vehicle has traveled. So that is d3. So these are the three components of uh, the overtaking side distance. So there's one more simple equation for overtaking side distance, which is say they will give you directly what is the overtaking maneuver time. So they will give you some time, which is overtaking maneuver time, which will comprise of both D1 and D2. Say they will say it takes 14 seconds for me to complete both D1 and D2 action. So you can simply multiply that 14 seconds with the design speed of the vehicle to find out D1 plus D2. And also, here if you want to separate D1 and D2, they say that you will find out one total distance D, right? As D is equals to Vd into this overtaking maneuver time. So this is total D. And if I want to separate it out into D1 and D2, so you take 2/3 of this D, that will be equal to D2, and 1/3 of D will be equal to D. Okay, so this is a very simple equation which simply says that overtaking maneuver time is the time taken for me to complete both actions for both actions D1 and D2, and out of which 1/3 of the total distance is goes to D1, and 2/3 of the total distance goes to D2. So this is very simple. Now what will happen to D3? D3 also they say that D3 is 2/3 of the entire D, overtaking maneuver time D. Okay, so you can simply find out overtaking side distance D1 plus D2 plus D3 as Vd into OMT plus 2/3 of Vd into OMT, which will be 1.67 Vd into OMT. So this is a very simple and straightforward equation. Okay. Now let us move on to horizontal curves. So horizontal curves, I just want to move faster because we have problems to solve. So yeah, so let us say I'm traveling on a horizontal curve, okay, curved location. Then if I'm at this position, if I see a vehicle here, this is my line of sight. Okay, then this is the direction along which I travel. So this distance, this curved distance in front of me till the obstruction should be minimum of SSD. SSD, same formula that we used. Okay, you can take into consideration the effect of grade or the effect of braking efficiency, all that. So FFT equation, so SSD equation is the same. So what is the problem here? So what is the thing that you want to calculate here? So there's something called as the setback distance. You say that if I want this horizontal side, so if I want the side distance SSD here, then my obstruction, say there can be any building here, okay? So beyond this, your view is restricted. So I'm here, my line of sight is here. Beyond this, there are buildings which affect my visibility beyond this section, okay? Now, so this is what I will call it as the setback distance, that is from the center of the roadway to any obstruction which is there in the turning, that I will call it as the setback distance. So this setback distance should be such that I should be able to see till here. Only then my distance from the point of from my location of vehicle to the obstruction here, it will give me SSD. So the problem here is SSD, you know the calculation. So you simply have to find out what is the setback distance. So there's a formula to find out setback distance. Uh, there's less time. Maybe, okay, we will just discuss setback distance briefly, then we will go to problems. Okay, yeah. So setback distance, say I'm having a curve here. This is my road. This is the length of the curve. The total distance is the length of the curve. And this distance is SSD. Okay. Now I have to find out. Now my obstruction is here. Okay, my obstruction is here. That is, some building is here. So my line of sight from this point to this point, passes like this. Okay, and say this is the center of my roadway. This is the edge of, sorry, this is the center of my roadway. Okay, yes. Sorry, I'm drawing poor diagrams. So let me discuss it with this diagram itself so that it will be clear. So this is the SSD. SSD will always be calculated with respect to the inner length. Why? Because on a circle, always the inner radius will be lesser than, so the inner distance will be lesser than the outer distance, right? So it is always safe to calculate SSD on the innermost lane. And also on the innermost lane, say my lane is for a width of 3.5 meters, I won't be traveling at this edge, right? I will be traveling at the center of the innermost lane. So I will always calculate SSD for the center of the innermost lane. So SSD, so this is my innermost lane and this is the so this is the center of the innermost lane. Okay, then setback distance will always be given from the center of the roadway. So center of the roadway and center of the innermost lane is different. Okay, so this is the roadway. This is my center line of the roadway, and my roadway has, say, 4 lanes. Okay, so 1, 2, 3, 4, and this is going to be my innermost lane. So SSD will always be calculated with respect to this distance, so this lane, okay, this position. Now, so I will take some distance, which is d between, which is the distance between the center line of the roadway and the center line of the innermost lane. So this is very important in calculation. Now how I will go, if I draw it is going to make things worse. So I will just show you this figure. So I need what is m, right? See here, this is m. Okay, this is m. Now how will I find out this m? This m will be, so this entire distance is the radius of the curve. Okay, so that is r minus, so from this entire r, I have to minus this distance. So what is this distance? I can easily calculate that from this right angle triangle. So if you just use Pythagoras theorem, this distance will be r minus d cos alpha by 2. So how will I find out this alpha by 2 will also be given, will also not be given. So that also I have to find out. So how will I find out this alpha? So if this is my entire curve, okay, this is my entire curve, and this is my SSD. Okay, so this is my SSD. So angle subtended by an arc of radians alpha will be the length of the arc will always be equal to, so length of the arc is SSD will always be equal to this radial distance r minus d into, so this distance is r minus d. If you see from this figure, it will be equal to r minus d into the angle alpha. So from that you can find out what alpha is. So this is when SSD is less than the length of the curve. So this equation is for SSD greater than length of the curve. So this is based on circular geometry, right? So you say that radius of the curve minus and all that. Here you cannot use that because you can use only that equation only till this position, because only till length of, so the length of the curve is circular. So the curve is circular with the radius r, but SSD is beyond the length of the curve. So up to this length of the curve, you can use the circular geometry, calculations using the circular geometry, and beyond that, you have to find this distance using a right angle triangle. Okay, so this extra distance also you have to calculate. And then based on this distance, you can find out what this m is. Okay, so this is how this equation is determined. If you want, since we are running short of time and we have problems to solve, we'll move ahead. If you have any doubts, please feel free to post in the discussion forum. Okay. Sorry, anyone has any questions? Yeah, so quickly we will see, now we saw side distance on a horizontal curve. Now we will see what side distance is on a vertical curve. So side distance on a vertical curve, the side distance is always restricted by the grade of the section, right? If you're, if there's a, if there is an upward gradient in front of you, you cannot see beyond a certain point. So you say that for an upward gradient, which we call it as a summit curve, the minimum side distance required will be equal to SSD. Okay, so this is what um, side distance on a summit curve is about. Whereas for a valley curve is for a downward curve, downward, and then it will go upward. Okay, so it is like this. It will go, if you see this figure, it will go downward and then go upward. So for this case, during daytime, you won't be having any problem because you will be able to see the entire length of the curve. Whereas during night time, the visibility ahead and in front of you will depend on your headlight beam. Okay, so how much distance your headlight can illuminate the distance ahead of you will be your side distance. So will be the distance visible in front of you, and that distance should be a minimum of SSD. So in valley curve, nighttime is a problem, and this nighttime, so that is what we will call it as headlight side distance. Okay. So this beam will also be not, so if this is my vehicle, my beam will not be straight, but it will be at an angle. Okay. So that angle will also play a role. So it will be at an upward angle. So this angle will also play a role in eliminating this distance in front of me. So that distance at night time should be a minimum of SSD, because only then if an obstruction crosses me, I will be able to stop my vehicle carefully, safely. So there's something else called as intersection side distance. So intersection side distance is, say, if so this is an intersection, right? So if there's a signal in an intersection, there is no problem. You will stop the vehicle. You know, because you anticipate, you know what is going to happen. You know that there will be a red light at a single signal, there will be a green light at a signal. So you know when to stop and when to restart your vehicle. But for an uncontrolled intersection, so controlled intersection is when you have signals. When you have an uncontrolled intersection, or say a priority intersection. So we will see what uncontrolled and priority is. So in both the cases, you need to provide SSD. Why do we need to provide SSD? Because there will be vehicles traveling in this direction and there will be vehicles traveling in this direction. So there's not going to be any control. You have to judge and cross the road on your own. No one's going to tell you when to stop the vehicle, whether you should stop the vehicle, whether there's a vehicle coming like coming in front of you. So all that you have to make your own decisions. For that, you need to provide a minimum of stopping side distance. So let us say this is my intersection and this is my uh, one vehicle is traveling here and my vehicle is traveling in this direction. So this is the point of collision, right? From so if at all my the two vehicles were to collide, they will collide at this point because they will cross each other at this point. Okay. So from this point, you have to check whether there is a distance of SSD in this direction for the vehicle traveling in this direction and SSD in this direction for the vehicle traveling in this direction. So based on that, you will have a side triangle now. So this is what I will call it as the side triangle. My vehicle is here. So at this point, this is the collision point. From here, I should have a distance of SSD in this direction and SSD in this direction. Okay, my vehicle, one more vehicle is here. So only if I'm able to see this, so this is vehicle A and this is vehicle B. So if vehicle A is able to see vehicle B only at this, if it is visible at this point, only then my vehicle will be able to stop or slow down and make a decision. So this is my, so there has to be a line of sight like this. Now if there is any obstruction here blocking this line of sight, then my sight distance will decrease, because if there's a obstruction here, my vehicle will not be able to see vehicle B at this point. It will be able to see vehicle B only at this point, maybe. If there's an obstruction here, then there's no enough decision for me to stop the vehicle. So in that case, if there's any obstruction here, either I have to remove the obstruction. Say if it is a tree or something which is removable, then I have to cut down the tree or remove the obstruction which is there in the line of sight. If not, if it is a building and if I can't do anything about it, then you have to provide a proper sign saying that reduce the speed of the vehicle, and for that speed the SSD should be satisfied. Say for a speed of 70 km per hour, the SSD required is this much, and my vehicle A can see vehicle B only at this point, then my SSD available, the distance available only this much, right, is only this much. Say this is D, much lesser than SSD. Then based on this D, you back calculate and find out the speed of the vehicle with which it should travel so that the stopping side distance becomes equal to D. I hope this is clear. So if there's any question, please type it in the chat window. We will discuss it at the end. Now we will solve problems. Okay. Yeah. So first problem, it is advised to restrict the construction activity up to building line beyond road land boundary. For what? So we saw what building line is, and let us see the options. So is it to cater to future expansion? Obviously, because if you have any additional lanes in the future, you need that additional space for that. That is why we mark the road land boundary. And ensure adequate visibility for vehicle on the carriageway. That also we discussed, obviously. So next one is to provide roadside plantation. No, this is not an option. So the answer to this question is options 1 and 2. Okay. Now moving on to the next problem. On a two-lane two-way carriageway, the SSD provided was 120 meters. If one lane goes into maintenance operations, what is the safe operation on this vehicle, on this section would be? So there is a two-lane two-way. This is two-lane two-way. Now, if this goes into maintenance, both the vehicles will be traveling in one lane only. So if there's only one lane and then a vehicle is traveling in both the directions, then both the vehicles should have a distance of stopping side distance ahead of them. So this should have a stopping side distance of SSD, and this vehicle should also have a stopping side distance of SSD. So if there are two vehicles approaching each other, there should be a distance of 2 into SSD, so that when they stop, they don't collide into each other. Okay, so when it is a one single lane two-way road, okay, then the uh, safe side distance that is required is 2 times of SSD. If SSD is 120, then the safe distance is 2 times of SSD, which is 240 meters. Okay. Does anyone have any questions? Okay. So moving on to the next problem. The design speed on a 4-lane divided carriageway passing through a built-up area is 60 kilometers per hour. So design speed is 60 kilometers per hour. The gradient of the road is 2.5, n is 0.025. So 2.5 in proportion in fractions will be 0.025. Considering the PRT, so perception reaction time is 2 seconds. G is also given 9.8 meter per second square, and coefficient of longitudinal friction. So F is 0.36. The highest value of SSD that should be ensured on this divided carriageway is what? Okay, so SSD is equal to lag distance plus braking distance, right? So lag distance will be VD into TR. So which will be 60 into 1000 by 3600. kmph I'm converting it into meters per second. Okay, so that is why I'm multiplying that by 1000 by 3600 into TR will give me a distance. Okay, that if any one of you has a calculator, you can calculate and let me know what this distance is. So this is the lag distance. Now what is the braking distance? Braking distance is Vd square by 2gf. So Vd square will be 60 by 3600 into 1000, the whole square. So plus n, sorry. So the gradient is, it is a upward gradient, right? Okay. This is plus or minus n, right? So for a gradient. So that divided by 2g into what is f? 0.36 plus or minus 0.025. So what do you want to take? Do you want to take plus or minus? They have not given whether it has to be an upward gradient or a downward gradient. So what will you take? They've asked for the highest value of SSD, right? We saw something that SSD will be more if the gradient is a downward gradient. For an upward gradient, SSD will be less. So since they are asking for the highest value of SSD, you have to take it as a downward gradient. So you will use negative here. Okay. So this you can calculate, and so total SSD will be L plus B, that is lag distance plus braking distance, which will be somewhere close to 75.66 meters. Okay. And now moving on to the next problem. So the minimum visibility along the center line of the inner line of the carriageway laid with a horizontal curve should be equal to what? So we saw horizontal curve and we said that we always take the inner line of the inner lane, and we said that the distance should be equal to minimum of SSD, right? So on a horizontal curve, the answer is stopping side distance. Okay, and moving on to the next problem, the reaction time of a driver. So the reaction time of a driver, uh, if you see the factors affecting the perception reaction time of the driver in sir slides, you will see that the reaction time of the driver decreases with an increase in speed. Okay, so this is the solution to problem 5. Now moving on to the sixth question. Friction between the tire and the pavement will be lowest when the pavement surface is what? How? Okay, so we saw that if the pavement surface is rough, friction will be high. If the surface is wet, the friction will be low. So when will it be the lowest? When it has a combination of both a smooth pavement along with a wet pavement. So the lowest friction will be when the pavement is both smooth and wet. Okay, this makes sense, right? So moving on to the next question. On a dry pavement surface, the coefficient of friction of a new tire is how much? So for this thing, it will be, so this is a new tire. So for a new tire, we saw it will have treads, and if it has treads, it is going to have a better friction. So let us, for comparison, take an old tire with worn out treads. So it will be smooth, so the friction will be less. Okay, so for a new tire, will it be equal to that of an old tire? The friction will the coefficient of friction be equal to that of an old tire? No, because this has a threaded surface, this has a smooth surface, so this is not the answer. Will it be greater than that of an old tire? One second. So it is also not going to be greater than that of an old tire. Okay, I'm sorry, I made a mistake. So it is actually going to be lesser than that of an old tire. So even if it has treads, this old tire, okay, will have a more contact area on the pavement than the new tire. So new tire will have a lesser coefficient of friction. So since it has treads, the contact area of the new tire will be lesser when compared to that of an old tire. So the coefficient of friction of a new tire will be lesser than that of an old tire. Okay. So moving on to the next problem. It is advisable to provide intermediate side distance. So we never spoke about intermediate side distance anywhere. So it is said that if you're not able to provide overtaking side distance, then you have to provide intermediate side distance. And what intermediate side distance is? It is nothing but twice that of stopping side distance. Okay. Also, you provide this intermediate side distance in an intersection. So there are two cases in which you require intermediate side distance. One is at approach to an intersection, and the other is when overtaking side distance cannot be provided. So the answer to this is both 1 and 3. Okay. And now moving on to question 9. The design speed for a multi-lane divided carriageway is, so VD is 80 kilometers per hour. The preferable side distance that should be available on this road section to ensure better visibility and decision making is what? So what are they asking you to find? They are asking you to find the stopping side distance. Okay, so there's one keyword here. It is said that it is a multi-lane divided carriageway. So when it is a multi-lane divided carriageway, the side distance that is required is not SSD, but it is twice that of SSD, because for multi-lane they say that you require a better visibility, so you will not provide SSD for safe movements. You have to provide twice the SSD of safe movements. Okay, so um, so SSD, how will you find out? It is simply lag distance plus braking distance. So in sir's slides, you would have found this equation. SSD lag distance, it is 0.278 V into PR, and braking distance. So this is lag distance, and braking distance is equals to V square by 254 F. Yeah, right. Now, how did you get this 0.278 and 0.254? So this is nothing but they have given you, in most of the cases, they will give you velocity in terms of kilometers per hour. But length, distance, you will always find out in terms of meters, in units of meters, right? So in order to make the unit conversions from kilometers per hour to meters per hour, meters per second, they use this 0.278. How? So velocity from kilometers per hour, if I multiply it by 1000 and divide it by 3600, this converts kilometers to meters, and 3600 converts hours to seconds. So if I do this, I will get 0.278 V. So this is what is used in directly in this section. Okay, so instead of multiplying it by 1000 and dividing it by 3600 everywhere to convert kmph to meters per second, we can simply use 0.278 in front of V. Similarly, this v square also, it is a squared term, and it one second. Yeah. So this v square by 2gf, right? So v into 1000 by 3600, the whole square, divided by 2gf. So 2g, you know that it is 2 into 9.81. So this is also constant. So 1000 by 3600, the whole square also you can find out, and collectively you can take it as, so it will be 1 by 254. This entire term, okay, it will be 1 by 254. So you're simply taking it as v square by 254f. Okay, this is how the numbers came. So you can simply substitute that in this equation and find out what is SSD. So SSD is equals to 0.278 into 80 into 2.5. So this is the lag distance plus 80 square by 254 into 0.35. This is the braking distance. And this will be equal to 127.59 meters. Okay, so this is SSD. So for multi-lane divided highways, you need 2 times of SSD. Okay, so which will be equal to 254 meters. Okay, so this is the answer to this question. Now moving on to the next question. So this question is for both 11 and 12. Now, the design speed on a two-lane two-way carriageway, so VD, is 65 kmph. Okay. A part of the section of this road is laid at a gradient of 1.5%. So N is 0.015. So it is nothing but 1.5 divided by 100. Okay. And perception reaction time, they have given it as 2.5 seconds. F is equals to 0.36. G is equals to 9.81. Overtaking maneuver time is equals to 11.5 seconds. They've given all this information just to confuse you. All they want is overtaking side distance for a level stretch. Okay, so what is overtaking side distance? We saw a simple method to find out overtaking side distance. It is nothing but overtaking side distance. They say that it is a two-lane two-way. So two-lane two-way means you have to find out D1, D2 and D3 and add everything up. Say if you have only a say if you have a divided carriageway, say this has a median in between, there's no way of vehicles coming in the opposite direction in this lane. So you have vehicles moving in only this direction. In that case, there's no need to find out the distance d3 which is covered by the opposing vehicle. So in that case, your overtaking side distance will only be d1 plus d2. Since here they have said that it is a two-lane two-way carriageway, which means it has two lanes and it has vehicles traveling in one lane in this lane and in the opposite direction in this lane. So in that case, you have to move to the opposing lane to make the overtaking maneuver, and so you have to be careful of the vehicle coming opposite to you. So you have to find out D3 as well, and you have to add D1, D2, and D3 to get overtaking side distance. Okay. So if you we saw a simple equation, right? To find out overtaking side distance based on OMT, it is VD into OMT. This is D1 plus D2. This contributes D1 plus D2 plus 2/3 of VD into OMT. This will give you D3. Okay, so this is my overtaking side distance. So let us find out overtaking side distance. It is equal to convert kmph to meters per second. So 0.278 into 65 into 11.5 plus 2/3 of, again the same thing, 2.78 into 65 into 11.5, and that will be equal to 138.38 meters. So this is my OST, overtaking side distance. Okay, now they've asked for overtaking side distance on a gradient. So if you see our slides, it would be said that overtaking side distance does not depend on gradient because both the vehicles will be having the same effect, right? So if your vehicle B, which we saw in the figure, is affected by gradient, vehicle A is also affected by gradient, vehicle C is also affected by gradient. So uh, the effect of gradient will be nullified. So overtaking side distance does not depend on gradient. This is an important point that needs to be noted. So overtaking side distance on a level surface and on the gradient will be the same as 138.38 meters. Okay. Now moving on to the, okay, is anyone asked any question? Dinesh, you want to ask something?
Ma'am, please once again explain this previous question as I have not understood that well.
You meant the overtaking side distance?
Yes, ma'am. Previous
Okay, yeah.
question that you have explained recently.
Yeah, sure.
Okay.
Yeah, okay. So this is the question. So they have given you all unwanted information. I told you we saw two methods to find out overtaking side distance. One is they will just give you the overtaking maneuver time. That is the time required for the vehicle to complete the overtaking action. So there are three vehicles involved. If you see that figure, vehicle A, which is our vehicle, say we are going to make the overtaking action. So vehicle B, which is the slower moving vehicle, which is in front of you, and vehicle C, which is the vehicle that will be traveling in the opposite direction. Okay. So these are three vehicles that are involved in the overtaking maneuver. So if this is the road, my vehicle A is here, A, B, and C is here. Okay, so the time taken by vehicle A to to decide that I'm going to make the overtaking action, that will be D1, distance traveled by vehicle for some time behind vehicle B to to make the overtaking action. So that distance we will call it as D1, and for vehicle A to move to the opposite lane, accelerate, go in front of B and go back to the same lane. So this distance is the overtaking action. We will call it as D2. Collectively, the time taken for making both, so the time taken for making these two actions, D1 and D2, is what they have given it as overtaking maneuver time. And they say that to complete this action, for vehicle A to move from this position to go back to this position, they say that it takes 11.5 seconds. Okay, so you saw that OSD is nothing but D1 plus D2 plus D3. So D1 plus D2 you can simply find out using this overtaking maneuver time, which is 0.278 into 65. So 0.278 converts this velocity in terms in kmph to meters per second. So this Vd into OMP. So if I do this, I will get D1 plus D2. Okay. Now I require D3. So what is D3? D3 is the distance traveled by vehicle C from this point to come to a point parallel to B, parallel to A. So this distance is called as D3. Why do we need D3 also? Because we are protecting our vehicle from head-on collision uh, with an opposite vehicle traveling in the opposite with a vehicle traveling in the opposite lane. So that D3 distance should also be provided if there's going to be vehicle coming opposite to me during the overtaking maneuver for me to safely complete the overtaking maneuver. Okay, so this distance D3, it is nothing but you found out D1 plus D3, D2, right? So it is 0.278 into 65 into OMT. You simply multiply that by 2 by 3. So D3 is nothing but 2/3 of the distance covered by D1 plus D2. Now you have D1 plus D2 as D1 plus D2 you had as 0.278 into 65 into 11.5, and D3 is equals to 2/3 of this, 2/3 into 0.278 into 65 into 11.5. So if you add all these three, you will get overtaking side distance. Is this fine, Dinesh?
Yes, ma'am.
Oh, yeah, yeah. So now moving on to the next problem. So we saw that 11 is for a leveled surface, and 12 they've asked the same problem for a gradient. And we saw that overtaking side distance is not affected by gradient. So for both 11 and 12, the answer is the same. Now moving on to traffic is moving at a speed of 60 kilometers per hour on a two-lane, two-way highway. So I will take this question and paste it somewhere else. Hmm. So traffic is moving at a speed of, so VD is 60 kilometers per hour. The overtaking has been prohibited on this section due to heavy traffic flow. Considering the overtaking maneuver time, here also they've given overtaking maneuver time as 10.8 seconds. The desirable length of overtaking zone will be what? Okay, in some cases they will prohibit the overtaking maneuver. They will say that overtaking not allowed. Okay, so they give you signs to say that you cannot make an overtaking action. So in that case, what they will do is, but you cannot simply be traveling behind a slow moving vehicle all the time, right? So they will give you a chance to overtake that slow moving vehicle in certain sections of the highway. Say my vehicle, so this is my highway, this is my two-lane, two-way road. There will be a section in which they will say that they will call this as overtaking zone. So they will say that you can make the overtaking action, you can do the overtaking action only in this section and not anywhere on the highway. So this is what we will call it as overtaking zone, and this zone will be 3 to 5 times of OSD. So you know how to find out overtaking side distance. You multiply that by 5, that is the desirable. So the highest case you will give it for overtaking zone. So you multiply that by 5 and you will say that, and you will provide that distance in the middle of some highway, and you say that this is the overtaking zone and you can overtake a slow moving vehicle only in this zone. But if you cannot provide such a long distance, such as 5 times of OSD, you can provide 3 times of OSD. So the overtaking zone distance can be 3 into OSD that you find. Okay. So so for that is they've asked you the desirable length of the overtaking zone. So this is nothing but 5 times of OSD. So OSD we know how to calculate. It is 0.278 into 60, similar to the previous problem, into 10.8 plus 2 by 3 of, since this is a two-lane two-way, we will have D3 also. So this is what D3 is. So 0.278 into 60 into 10.8. So if you calculate this, you will get 300 meters. Okay. Now what will be my what will be my overtaking zone length? It will be 5 times of OSD, which is 1500 meters. Okay. Now moving on to the next problem. Problem 14. So the design speed on a curved section of a 4-lane divided highway is, so design speed is 80 kilometers per hour. The distance between center line of the alignment and the center line of the innermost lane. So we saw that so SSD is always calculated with respect to the center line of the innermost lane. Okay, so this is where you find out SSD. Okay, so the distance between this center of innermost lane to the center of the highway, we saw that it is equal to D. Okay, and the length and radius of the curve. So length of the curve is, they have given it as 250 meters. Radius of the curve, they have given it as 250 meters. And the setback distance to have clear line of sight. So SSD, they have given it as 127 meters. So they are asking you to find out the setback distance. So it is a straightforward question, right? So what is the formula? SSD is equals to what? 127 meters. So you know that SSD is less than LC. So there is an equation for SSD less than LC where M is equals to R minus D cos alpha by 2. So R you know it is 250, D you know it is 7.5. It is they both are given in the question. Alpha is what you don't know, but we saw an equation to find out alpha also, where alpha is equals to SSD divided by R minus D. Okay, so that will be 127 divided by 250 minus 7.75. So D is 7.75. I'm sorry. So D is 7.75. So that will be equal to 0.5247 radians. Okay. Now this you have to convert it into degrees because alpha is angle, right? So you have to convert it to degrees. It will be 3.037 degrees. Now you have to find out, you have to substitute this in the equation of M. So M is equals to R is 250 minus 250 R minus D, 250 minus 7.75 into cos of 30.037 divided by 2. So this will give me 16.02 meters. So this is the value of the setback distance. Okay. Now keeping rest of the conditions to be same, the stopping side distance on an ascending gradient as compared to a level surface is what? So we saw that stopping side distance on an ascending gradient will be less, right? On a descending gradient it will be more, and for an ascending gradient it will be less. Now, one second, I think I missed some question. Yeah, I missed a question here. So select the correct statement considering two-way movement of traffic on a two-lane carriageway. So you have to find out, you have to choose the correct sentence. So high beam is a contributing factor in traffic accidents as it produces glare effect. It is true. We will see how. Horizontal angle of headlight beam defines the visibility of carriageway ahead. So if this is my headlight, if I see the vehicle from top, this is my horizontal angle. Okay. This is just going to cover the carriageway but not provide visibility ahead of, it is not going to provide visibility on the carriageway ahead. Whereas if this is my vehicle and this is my light beam, so this vertical angle, so beam will have a vertical angle and a horizontal angle. Okay, horizontal angle will just give me coverage of the carriageway, whereas my vertical angle will help me to see the roadway ahead to a longer distance. So these both this horizontal angle and vertical angle have been interchanged, right? These options have been interchanged. So horizontal angle gives me coverage and vertical angle will give me visibility on a carriageway ahead. And stopping sight distance is more than overtaking sight distance? No, because overtaking sight distance, as we saw, it has many number of terms and it is obviously going to be more than stopping sight distance. So if you want to check with this answer, you can see I have a snapshot of Sir's slides. So it says that high beams may cause glare effect. That is what we selected as the correct answer. Horizontal beam. So this is the vehicle plan. We are seeing it from the plan. So this is the horizontal beam. This helps you to have more coverage of the carriageway. Okay. Whereas the vertical beam. So this is the elevation of the vehicle and this is the vertical beam of the headlight. Okay, this will help me to see a longer distance. It will not cover the carriageway, but it will help me see ahead. So vertical beam will help me see ahead and horizontal beam will help in the coverage of the carriageway. So these options have been interchanged. That is why we selected that these options are wrong. Okay, so there are two more problems which I have taken from elsewhere. So this is taken from a book and this is taken from Google. It is very simple. You just have to find out SSD. Here they have given two drivers with the same reaction time, but they are traveling at different speeds. So uh, both your lag and braking distance will vary because their speeds are different. Okay, the reaction time is the same. They have given a downward gradient of 2.5%. So it is a very straightforward problem. You can solve this problem and one of you can give me the answer in the next session. Okay. And the next problem is it is nothing but the problem to find setback distance. Here it is the same as what we saw here. Okay, here also we saw SSD is less than the length of the curve. Why I took this problem is length of the curve. Why I took this problem is here they would not have given you the value of D. Here they would have asked you, they would have simply said that there are 4 lanes and each lane has a width of 3.5 meters and they would have asked you for the setback distance. Okay, and they would have asked you for the setback distance from the inner edge of the highway. Okay, so always setback distance. So if this is the road, radius is always given with respect to the center line of the road, and also the setback distance is also given from the center line of the road. Here so if this is the setback distance, usually in this problem they are asking you the setback distance from the inner edge of the road. So they are asking you for this distance. Okay, so you have to subtract this distance, which will be 7 meters. Why is it 7 meters? It is a 4-lane road, so it will have with respect to the center line, it will have 2 lanes on that side and 2 lanes on this side, and each lane has a width of 3.5 meters. Okay, so you have to minus 7 meters from the setback distance that you get to give the final answer. And also they have not told you how to find out, they have not given you the value of D. In many cases the value of D is given, but in this problem it is not given. So how will you find out the value of D? So D is nothing but the distance from the center line of the road to the center line of the um, inner lane of the carriageway. Okay, so they say that there are 4 lanes. So this is the center line of the road. There are 2 lanes on this side. Okay, so 1, 2, 3, 4. So from this center line, so from the center line of the inner lane of the road to the center of the carriageway is what is D. So how will you find out D? Each lane is 3.5 meters. So D will be 3.5, this distance, plus 3.5 divided by 2. Okay. So this is how you will find out D. Okay, I hope this is clear. Maybe one of you can solve, or some of you can try this problem and show me in the next session. Okay. So does anyone have any questions? Dinesh, you have any question? I see that you've raised your hand. Okay, if any of you have any questions, please feel free to post in the discussion forum. This video will be um, published on YouTube maybe by tomorrow or so, and the link will also be shared by the NPTEL team. So just refer to it. So if there are no more questions, we can end the session. Okay. So thank you all. Dinesh, you have a question?
Hello.
Yes, Dinesh.
Ma'am, is it okay that I will ask you the question from previous session? Hello, sir.
From what? I cannot hear you.
Regarding first assignment, ma'am.
First assignment deadline is not over yet, right?
I have one small doubt over there, ma'am. That one
Uh,
question I have gone through. One
okay,
question is there to calculate the number of lanes.
okay,
So I have gone through the detailed lecture of yours,
okay.
but I didn't get that answer. So is it possible, ma'am, for you to give this understanding for that particular question? I
Uh,
think it is a question number 7.
Actually, I don't have access to it now. Like, can you just type the question in or just show me? The deadline is day after tomorrow, right? I cannot help you till then. After that, we can discuss. Or
Okay, ma'am. No.
yeah, after that we can discuss. We'll discuss in next sessions in the next
Okay,
session.
ma'am.
Okay.
Okay, ma'am. Thank you, ma'am.
Thank you. Thank you.
Okay, okay. Thank you.
Yeah. Thank you all.